Hello explorers and welcome to another video. Today I'm gonna talk a little bit about tf.data or Tensorflow data. And this come about because I watched the Tensorflow summit and they talked a lot about Tensorflow data and this new API that you can use to actually make things easy for yourself, easily read data into your system and easily make better performant models. And I thought that was really interesting, so I wanted to try it out. So I went to their homepage and looked at the documentation, and I thought it was quite hard to follow. So I actually wanted to make this video to give you an understanding on how you can set it up and how you can get started much quicker than I actually got. And everything that I will show today is up on my GitHub, so you can see it there. So let's get started. We are talking about code. And first off, we have two feature functions here. And these are just wrapper functions that will take some value and wrap it inside of a byte list or an int64 list, so an int of size 64. So these are just some simple functions to make features of data. And then we have this little load image function. It takes an image, it resizes it to one size and then changes the color to RGB. So that's what I want my image to be when I actually are working with them. And all the images that I load today come from a dataset that were a competition of some sort to train cats and dogs images and see if we can figure out what's a cat, what's a dog. And and this image set has a lot of different sizes of images and so on. So if you actually want to make this a viable set, you should actually look at the images, maybe filter some of them out, maybe do some steps in the images to actually make the classification more viable and get a better trained model. And usually when you're working with data sets, you really want to find good solutions to actually clean up your data sets as much as possible. And of course, if you want to find things in dirty data sets, then you might want to train with dirty data sets as well. But as we don't build a function that will find let's say a dog in an image, we just want to see if this is an image of a dog, then it might be better to do that beforehand. And then we have the next function here will actually create a data record, and these are the TFRecord files that the tf.data will use when it reads in. tf.data can read CSV files and other files, but they are good at reading binary TF-records. So this is the way to create those. And you create a writer from Python.io, TF-record writer, and the output file name. And then I have a little function here, so I go through all the addresses of all the images, and I take a little printout each 1,000 that I do, because there are I think 25,000 images, so it could be good to have some progress, so you know how much you have actually read. I load the image, I take the label for that image. If I didn't get any image, then skip this one. And then I create a new feature with the wrapping of bytes for the image, and then I wrap the label with an int64, and then I create an example. So I wrap everything in the feature which I wrap in an example, and that example I will serialize to the writer and write out the file. And when I've done, I close the file and flush everything out. And when I create this, you will get 3 different files. I will look at those later, and those are in the range of 8 gigabytes and 2 gigabytes. So they're quite large. So you need to have some space on your disk if you want to run this example. And then I set up a path, a glob, to where my images are. So in my directory pet images, I have cats and dogs. So this star here is the cat directory and the dog directory. And then I have some JPEGs, and all the JPEGs are 1, 2, 3, 4, 5.jpg. And I read the addresses from this glob command, and the labels will actually take the address and then look if the address has the word cat in it. So if the directory is cat, you will set 0 in the label, else it will get a 1 in the label. And when I have created these, I will actually zip these together and create a list. I will shuffle that list, and then I will unzip that list again, so I will actually get the address and labels back. It's a really neat feature in Python, actually. I didn't know that you could do things like this. I'm not usually writing that much Python code, so it was really nice to see this. Another nice feature that you see down here is where I split up my training set into 60% training, 20% validation, and 20% test data. It's very easily done with these array ranges. And when I've done this, I will create records for the training addresses, the validation addresses, and the testing addresses. And I will put those in different files with their labels. So when I've done that, I have prepared the data and I have these large files. Then we will go into the training part of this video. So this is the training, and we first off look at setting up a new session and initializing the global variables. And then I have this parse function I have up here, and that will actually take one record from the TFRecord file and parse it out, so I actually get the label and the image out. So first off, I need to say what kind of features I actually had in my file. I have this tf_raw and the label, and these are strings and int64. So this is just to define how the data structure in the file is set up. And then I will read one record from the file, and then I will take the image raw part out and take bytes out of it and decode the raw image here. I will cast the image to floats because that's what the model needs, and I will also reshape the image so it actually is in the shape of the size of the image. So it's 224 times 224 and 3 colors, or a depth of 3. And then I will read out the label, and I will cast that to an int32 because that will be used in the model as well, and then I will return that from my parser. And the estimate I will use later will need an input function, and I will create this input function from this helper function I have here, and it will first off create my data record. So this is a data set of the TFRecord. So this is the tf.data we talked about earlier that you could do a lot of performance enhancements on and so on. So this is the API that I wanted to showcase in this video. And after I created my data set, I will map it through my parser. So I actually will parse the labels and the images. And if I'm in training, then I will shuffle them up. And if not in training, I will only repeat once and not shuffle them, because I want to have a good evaluation every time, the same. And then I will repeat and set up the batch size. So the batch size is 32 in this case. I make a one-shot iterator, and I get the batch of the iterators and return that batch back to the training function. So then I set up a training function here with the train records and the test records, and I set training to true, and then I do the same with the validation records, but I set training to false. So these are the train input function and the validation input function. The first, and you see here I have some code commented out here. It's just to print the image. I wanted to see that after I have saved it down and read it again, I wanted to see that I had the same image, so I can verify that I didn't do anything wrong in that process. And here I have feature columns that I want to run through a fully connected classifier. So I set up this one, and it has layers here, 128, 64, 32 and 16. So this is it was one of the networks that I tried, and it has an Atom optimizer, and I ran it through 100,000 steps, and it ran, I think, 4,000 per 10 minutes. So overnight I was able to run this little classifier, and I got about 49–50% right. So it was just like a coin flip. It was totally worthless. Or it wasn't more wrong than if I just guessed, but it wasn't good either. So then I wanted to try a little bit more sophisticated model. So I have my model function here, and I set up a network that we have seen before. It's one convolution with some pooling, then a convolution again with some pooling. We flatten the net, and then we do two fully connected layers. And then we take the predictions down here if we want to actually do predict something. So this is if we want to go into the predict mode of the estimator, then we need to take out the prediction and the prediction class. And if not, then we just put this result of the network into the spar softmax cost entropy with logits function. And we reduce and find how much loss we have. We run that through an Atom optimizer, and we return some metrics so we can see how accurate we are now. And then we create this estimator specification down here that we actually return. And in order to set up a new estimator that we want to run, we put our model function into it. We give it a learning rate, and that learning rate is used inside of the Atom optimizer. We set the model dealer so it knows where to save all the files when it does snapshots. And then we have a little function here where I go through 100,000 times again, but in this case I actually want to evaluate after 1,000 print the result and the accuracy, and then I flush it out, and then I try another pass. And I've run this for a little while. I was a little bit pressed on time, but the best, it started somewhere around 70%, and I think the best result I got was 71 or 72, something like that. And that could either mean that I have an unclean data set, so I might want to find a good function to clean it up, and maybe another function to crop the images so I don't lose that much when I actually resize them. Maybe I use too little of the image. Maybe I want to use larger images, but that will also slow down the training. And maybe I could fix my model. Maybe I can have a better model. I've just tried with this model, but that could be tweaked as well to get a better performance or accuracy in the model. But I think this is a good starting point, so you can see how you can set up things and actually get the TF-record working with Tensorflow data. And everything else after that is optimization. I hope that you found this video interesting. I hope that you learned something today. If you have any questions about Tensorflow data or the setup, then please ask in the comments below. All the code you can find on GitHub. I will leave the link below as well. And if you like this video, give it a like, share it with your friends and colleagues. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.